Hallo und herzlich willkommen zu unserem heutigen DVGW H2 Lunch and Learn. Heute ist eine Premiere. Heute werden wir das erste Mal sowohl eine Moderation als auch unsere ReferentInnen auf Englisch hören. Und deswegen werde ich jetzt auf Englisch switchen. My name is Frederick Kyle. I am Science Communication Specialist at the DVGW, and I will be guiding you through today's event. Before we dive into our topic and introduce our speakers, here are a few organizational and technical notes. The duration of the presentation will be 25 minutes. After that, we will have a discussion round with Q&A with the speakers. You can submit your questions to the speakers after the presentation via the Slido tool on the right side of our screen. And if you experience any technical difficulties, please click the question mark icon in the lower left corner of the stream window. There you will find the contact details of our technical support team. In many cases, simply refreshing the page or stream helps resolve the issue. Today's event will be also recorded and made available on the DVGW YouTube channel. And the slides you will see in a few minutes will be accessible on our Lunch and Learn webpage after the event. If you have additional questions after the event or cannot find the materials on the website, feel free to reach out to me or my colleagues. Our contact details can also be found on the DVGW Lunch and Learn webpage. And now to our today's topic. Hydrogen is a key factor in the German and European energy transition. The European hydrogen backbone is planned. The first parts of the German Wasserstoffkernnetz are already built. But how does hydrogen reach consumers who are not near the European hydrogen backbone or hydrogen transport networks? The answer: via distribution networks. The importance of these networks for hydrogen supply and the success of the energy transition is highlighted in a new study by Frontier Economics, commissioned by the Ready for H2 initiative. The study analyzes 9 European countries and outlines hydrogen supply scenarios for the upcoming decades. In this Lunch and Learn session, Barbara Jinks, Director of Ready for H2, and Anna Lane from Frontier Economics will present the results of this study and how crucial the distribution networks are for connecting hydrogen supply and demand. Barbara Jinks has worked as a pipeline engineer in many countries around the world, mostly Europe and Asia, and is on various intergovernmental organizations and industry boards as a gas advisor. She leads the Ready for H2 project, a consortium of nearly 70 European gas distribution operators and gas associations to promote the use of gas distribution grids to deliver hydrogen. Sorry for my pronunciation. In Germany, Ready for H2 is represented by the H2 vor Ort Initiative. Anna Lane works as a consultant for the intersection of data science and energy at Frontier Economics in Berlin. Some key relevant projects she's worked on have level in Austria and efficiency benchmarking analysis of gas distribution system owners in Germany. I don't want to take up any more time with my introduction, so I hand over to both of you and your topic. I'm excited to hear what you have prepared for us today. Barbara, I think we will start with you. The floor is yours.
Thank you, Philip. And you get an A plus for your pronunciation. And I actually think that DVGW is easier to say than DVGW. So, can you see my screen, Philip?
Yes, we can see your screen.
Great. So welcome everyone, and thank you, DVGW, for asking Anna and I to present a study that we worked on together for the for H2 project. I will give an introduction into the project, and then I'll hand over to Anna, who will talk about the methodology and the results of the study, and then I'll come back and give you an overview of what else we're doing. And because DVGW is a member of the Ready for H2 project, any of you who are DSO entities, distribution system operator or Gasnetzer, you can be a member of Ready for H2 and you can be involved in the work or a study group, or you can suggest topics that we should look at as a community and help you. So this picture shows The thinking at the moment, a lot of what we hear about is the European hydrogen backbone, the high pressure transmission network, which is essential to get hydrogen from the supply to the countries in Europe. But it's a bit like building an autobahn, but not having roads to get off it. You then need the distribution network to take the hydrogen from the backbone to the end user, and that's what we're looking at. Ready for H2 is the only initiative that is focused on hydrogen distribution. And we have nearly 70 DSOs and seven gas associations in 5 countries. And also, we partner with seven European institutes and associations. You can see them: Hydrogen Europe, European Research Institute for Gas and Energy, Eurogas, Gas Distributors for Sustainability, GD4S, Geode, GERG, and Marco Gas. Together, and you can see the company names who are members, and you can see that DVGW, DVGW, all DSOs are a member of Ready for H2 because DVGW is a member, but the Haasvijf Oord has allocated 8 companies who are very active and attend meetings and discussions. However, all 47 DSOs in Haasvijf Oord, as well as all the other DSOs in DVGW, can be a member. So together we operate 1.6 million kilometers of distribution pipe, which in the EU 27 is over half of the EU 27 distribution network. And together we serve over 90 million customers, and we have over 50 projects underway. So that's an overview. You will get these slides that have a lot more information than what Anna and I will share. The project is, it was started in 2020 because, as I said, we read and hear a lot about the backbone, about transmission, about converting steel pipelines to hydrogen. We hear a lot about hydrogen production, the cost, the logistics, the geopolitics, and we also hear about end uses and the need for industry and transportation to decarbonize, and where does hydrogen offer a solution. But the missing link really in the discussions in Brussels and in the text that policymakers issue, what's missing is the distribution grid, the link between the transmission and the end user. So this was recognized, and in 2020, a group of companies, mainly countries, Denmark, France, Holland, and Germany, and DVGW was very much driving this. They kicked off this community, and the community was established, and a knowledge sharing platform was established, and a survey was issued. And then we fast tracked through having done research and issuing a roadmap in phase 3 through to phase 4. That just means it's the 4th year of operation. And I'll quickly go through what we've been doing and what we're planning on doing for the rest of the year. The key thing for you all to know is that a couple of years ago, the roadmap was developed. So it's a transformation. If you are a gas distribution system operator and you want to get ready for hydrogen, what do you have to do? And here is the roadmap. This was done by the survey, the members themselves. So it's split into 3 areas. You have to facilitate access to hydrogen and a market. Then you have to convert your own system and your materials, your system, but also your people and your digital abilities. And then you have to actually deliver at scale. And that usually involves pilot projects, test projects, studies, and then actually getting ready to deliver at scale. We analyzed the status of our members along this roadmap, and we're looking at this year to do some deep dives into the areas that are the most challenging to help our members move faster along the roadmap. We also could have collected a database of all the projects that are being done that are related to developing from gas to hydrogen, and that is either repurposing, reusing, converting steel and plastic systems to hydrogen, but also building new grids but being part of the same business. And there's more information on that on our website. But today we're not talking about these studies. We will talk about the study that Anna will give us an overview of, run by Frontier Economics. The introduction to the study was, we think that we're essential. We know that gas is essential. We know that distribution grids are essential, but we couldn't really prove it in a tangible sense. So we wanted to make a visualization of the need for distributions. And this was done in the form of a mapping study. So Anna, if you would like to give an overview, that would be great. Thanks.
Yeah, hi everyone. Just a quick question before I start. Are we doing questions at the end, Philip and Frederick, or are we doing them as we
Yes.
go?
No, we're doing it at the end in our Q&A.
Okay, perfect. Yes, hello everyone. My name's Anna Lane. I'm a consultant at Frontier Economics, and I managed this study that Barbara just introduced. Feel free as we go along to post any questions in the chat, also in German, and we can answer them at the end during the Q&A session, as Frederick just said. So as Barbara had sort of already kind of gotten at, the role of DSOs comes about as sort of a geospatial question. So we need DSOs to fill in gaps between transmission supply and demand. To that end, Ready4H2 commissioned a geospatial study for 9 of their member countries, including Germany. And this study was meant to estimate how much hydrogen demand in the future would be DSO relevant, or in other words, would be needed, could be needed, let's say, to be transported by DSOs. This was a study that looked then at 3 Stichjahren, I don't know the English word, sample years, so 2030, 2040, and 2050. We estimated national demand in those years using kind of, let's say, industry data that's provided it's publicly available. And then we regionalized that data to understand, okay, where on a point or NUTS 3 level, so a very granular geographic level, is the demand, and how far away is that from transmission infrastructure, so namely the EHB or the CAN nets. We looked at this for 2 decarbonization scenarios. So a scenario with higher hydrogen demand that's looks at has a bit more technological diversity, and a more electrification-based scenario to try and understand if the role of hydrogen and therefore of DSOs is lower in an electrification scenario. So, and then we did this across sectors. So we looked at industry, both large and small and medium, transport, households and buildings, and then also the energy sector. So can you go to the next slide, Barbara?
Yeah, it's just a bit slow. There you go.
Nice. This is a very short presentation today, so I'm just going to focus on the main results between this and the next slide. Essentially, just to give you some context for how you get to the main result, as I just said, you're kind of doing a regionalization of demand from the Deutsche Kernnetz, or the European hydrogen backbone, to where the actual estimated demand is. And when you do that, we said, okay, if demand is 3 kilometers away from the EHB, then it's almost certainly DSO relevant. You need a DSO to transport this hydrogen from the CANnets to the actual consumer. If it's between 1 and 3 kilometers, there is potential need for DSO, but we're not exactly clear if it could also be TSO relevant. And then if it's closer to closer than 1 kilometer to the EHB, it will probably be transported by a TSO. So using these thresholds, we find that 50% of hydrogen demand across all of the sectors and across all of the Ready4H2 countries is DSO relevant. So we expect to be transported by DSOs. And when you consider a more generous threshold, you would even get to an additional 11%. So 61% of hydrogen demand in 2040 would be DSO relevant. When you look at other scenarios or other years, you come to broadly similar results. So this is the more balanced scenario, but if you looked at an electrification scenario, we're still getting around 44% of demand to be DSO relevant. These results encompass all of the Ready4H2 countries. When you look at it at a country level, the results might vary a bit. You can see the map on the right-hand side is for 2050. That, for example, in France, you have kind of a different picture going on than in Spain, than in Germany. In Germany, it's a bit complicated because the regionalization is very granular, which on the one hand is quite nice for precision, but it makes the map look maybe like it has some white space. But actually, Germany is one of the countries, or the country, with the highest hydrogen demand, and the highest DSO relevant demand. So we find in 2050 318 terawatt hours. That is DSO relevant. Barbara, can you go to the next slide?
Anna, if I may add, the map, the red lines is the European hydrogen backbone, and
Yes.
the CareNets, just to clarify. Okay, next slide.
And then if you look at this on a sector level, because I guess everyone in the industry sort of knows that the need for hydrogen is expected to vary very strongly by sector, with some industries requiring it kind of in any sort of decarbonization scenario, due to temperature and fuel demands, and other sectors like households and buildings having a much larger variation on what kind of fuels they can use. So we also looked at that kind of 50% headline result broken down on sector level. And also then within that, okay, with how much is DSO relevant? So you can imagine that large industry often could be connected directly to the EHB, whereas a household is never going to have a direct connection over a TSO to the EHB. So that while hydrogen demand in households and buildings is probably small, it is always DSO relevant. Whereas in industry, you might have large amounts of demand, but not all of it is DSO relevant. So there we're finding that the household and buildings one isn't that interesting. 100% is DSO relevant almost by definition. But the industry one is, and the transport one are both quite interesting. So there you do find, even within large and small industries, 71% of hydrogen demand is DSO relevant in 2040. So that's a large majority. And I mean, large industry is quite critical both on a economic level, but also in terms of there's not a lot of substitution to other fuels that can exist there besides biomethane, which also needs DSOs. So that's quite a positive results for the DSOs. And then within transport, we find 32% of sector demand is DSO relevant. This is primarily due to large dispersion of Tankstellen, so refueling stations, such that there's some amount of uncertainty around how many of those refueling stations will be directly connected to the EHB versus how many will be serviced by DSOs. But within road, and I think the other one we looked at, we didn't look at planes, but we looked at road and ship, we're finding about a third of demand is DSO relevant. So Barbara, is the next slide mine as well?
No.
Then I'll say like one or two closing words and we can move to you. Can you go back one slide then? Or yeah, that's also
fine.
I
have to also pop back in to sorry, show my screen again. So I'll go back one slide. Yep.
Yeah. So just as I said, a few closing words. The study reveals a really strong need for DSOs to transport hydrogen across years, across geographies, across sectors, across possible decarbonization paths. It's a really positive result for kind of messaging and lobbying from DSOs to governments on what role they will need to be playing. And that there are enough problems with hydrogen ramp up in the markets, and there really needs to be collaboration between DSOs and TSOs to sort of make that hydrogen market ready and get it to end consumers. And so, yeah, it was really a pleasure to do the study. If you have any questions, as I said, feel free to post them in the chat. I think also Barbara is publishing all of the results of this study. She can say a bit more on that.
So the full study is available to Ready for H2 members. It's on a Teams platform, private to members only. That means that any DEFA-GV DSO members can access it. But a public report is with the publisher. It could be ready next week or the week after, and that will be obviously the public report. Apology, Philip, I don't know how to get rid of this banner at the top. There you go, it's moved up a bit. Thanks, Anna. what this means is that the work we do, of course, has to translate into advocacy and messaging for policymakers. So we're being really clear that the messaging we say, we have backed it up with studies. We also did another study last year, which was revisiting the cost of repurposing distribution grids, and that's low and medium pressure steel and plastic. So with our hands on our hearts and with the scientific research and data, we can say that the energy transition in Europe is not achievable without the use of gas distribution grids. You can see that at least half, which means the majority of hydrogen, cannot get to the end user without the use of a distribution grid. Should we ramp up the hydrogen, and should all the end users be ready to take the hydrogen? But that's another issue. It's clear that we really need to start including the distribution grids in the planning of the future energy systems. And of course, the DSOs will continue to deliver natural gas, but also biomethane. So it's all green gases. And we're seeing a little bit of that with the ENNOH talking to the DSO entity. And the DSO entity about 5 weeks ago started including, because the DSO entity is electricity, and under the directive, it has to include gas DSOs, and that discussion has started. And the board is being created right now, and Acer is managing that process. Significant savings can be made by repurposing the gas grid. That is clear. And that is for all green gases, biomethane and hydrogen. And then, of course, using the distribution grid gives the flexible delivery of all of the gases. So it gives you flexibility for ramp up and solutions for the end users. And very importantly, and I know this is an exercise that Hasfai for Ort is doing right now, and that the DEFOGAVE is doing with the German government, is looking at regional development, where you do not need the backbone, you do not need transmission pipelines. You have your hydrogen production, and then you have industry or residential areas or hubs or hydrogen valleys. And of course, that would be by distribution lines connecting short distances, but over wide areas. And then our final conclusion is that there's no reason why gas distribution grids cannot be converted to hydrogen. The only reason it's not happening are because of external factors, such as supply and demand, uncertainties with pricing, but also that the regulatory and financial frameworks are not in place. So in conclusion, I would like you to know what Ready for H2 is doing this year, because last year was a year of studies. We did 4 studies: the project, the cost, the roadmap, and the mapping study that you've just heard about. This year we have 3 different working groups. We're really focusing on advocacy and communications, and every week I'm sharing results and talking and being part of think tanks. And we're now being invited to places like the UNECE, UNFCCC, really looking at how do we decarbonize energy. And it's great because distribution is now being included in those discussions because of the Ready for H2 work. So we'll continue that. Working Group 2 is really to continue possibly the most important fact about or offer that the Ready for H community offers. And the main reason that members join is to learn from each other, not to double up, not to make the same mistakes, and also to learn from the countries like Germany, who really are leading the research and the pilot projects and the discussions. So please think about joining. If your name is on our distribution list, every month we have a webinar, which is a deep dive, which you can listen to. So let me know or use the email on the website. But also, if there's a topic you think we should be looking at that you would like to know more about, let us know, make a request. And we'll continue to develop the lessons learned from the pilot projects, and that's become very valuable. The third themes that we're working on is understanding better the external factors that are affecting the ability of a distribution system operator in converting to hydrogen. And apart from things like I was saying, supply and demand, regulatory, it's also public perception, financial models. Germany's got that wonderful looking model for the hydrogen in the transmission system. And we need to know what the plan is for distribution as well. What are the tariffs? What about the investment? We also are planning a survey of what DSOs think about the decarbonized gas regulation and directive, and we'll feed that. We'll give that feedback to Acer and the European Commission. And then we're going to, as I mentioned, look at the lowest scoring results for the roadmap, our members, their status in tracking along the roadmap, what were the biggest challenges, and we'll have a look at them. You can see that each country has a representative on the board, the steering committee. It's like a board, and your Professor Dr. Herlinke is the representative for DVGW, and there's the other countries. And you can see that we have a very established network. My final comment is that the value of Ready for H2 is learning from each other and sharing knowledge. And you can see the matrix. The names in the squares is our members, who are also members of the 7 large institutes in Brussels. So we're pulling together information and making sure that everyone's got the same data and hopefully the same understanding of the role of DSOs and the potential for DSOs to deliver hydrogen. So my final request is please consider joining, or at least letting us know what you think the important issues are and taking part in any surveys. Philip, with that, I will stop sharing and hand back to you.
Thank you very much, Barbara. Yeah, and thank you both for the very interesting presentation and insights to the study. Now, let's move on to our questions, dear participants. There are a few in our. The first one is from Philip Kallhammer. Are there similar initiatives like H2 for Ort and the GTP in other European countries for the transformation of DSOs?
No, that's why we exist. No. No,
Perfect
actually,
answer.
no, there aren't. And again, Philip, the other Philip, the question, Philip, it's because it's just missing. It's lacking. I mean, H2 for Ort is world leading in what it does on a national basis. Ready for H2 is world leading in what it does on an international, regional basis. We will have a webinar where DVGW will share the next step of H2 for Ort in regional planning. And we're also talking about that, look, because DSOs don't cross borders. TSOs, transmission crosses borders. DSOs don't cross borders. But that doesn't mean it's not a regional development. Even though they don't cross borders, it's still regional. And for your info, other countries like the OAPE, the OPEC in Egypt, they want to copy the Ready for H2 model in the Middle East. So no, but we're working on it. Thanks, Philip.
Okay.
And join us, Philip, if you want to help us make that happen. Thank you.
All right. Then the next question is from Leo Lilienthal. Is there more information on the DSO-TSO network? Will there be communication before the kickoff?
Kickoff of what? I wonder. What's happening is the European Commission has recognized that distribution is part of the solution. And in the last gas package, the DSOs and TSOs were ordered to talk to each other and plan together. Now, how that is happening is a new ENNOH, the European Network of Hydrogen Transmission Operators, was created. So you have ENTSOG and ENTSO-E, gas and electricity, but you now will have a hydrogen, a separate one. Same job, same responsibilities, network codes, compliance, etc. The ENNOH will present all the hydrogen transmission companies, and the DSO entity will represent all the DSO, gas and electricity, and they'll talk to each other. So that, if that's what Leo means, that's where that happens. Nothing's happening at the moment. As I said, the DSO entity exists. You can look it up on the internet. but it's only electricity DSO. And whenever
Okay.
you look at the word DSO, you have to, are people thinking gas or electricity? So they have had to bring the gas DSOs into the DSO entity, and that's happening right now. And at the moment, it's just a negotiation on who gets the seat on the board. That's what's happening at the moment. And then Acer will approve the new board. The European Commission will then approve what Acer has recommended. Then the discussions start. So, Leo, nothing's happening at the moment apart from establishing the joint gas and electricity DSO entity. There will be, this is important, there will be, you know how we have the Madrid Forum for regulations on gas? There will be a hydrogen forum for the first time. It'll be in The Hague in February next year, and that's when it will be made public eventually that what's happening, what are the plans, what's the planning. So it's a little bit, it's in process. Good
Okay.
question, though.
Thank you very much.
Thank you.
Then the next question is from an anonymous participant.
Ooh.
How did you technically define a consumer as relevant? A, H2 usage is an option, or B, H2 is the best solution for the consumer?
Anna, we made some big assumptions, didn't we?
Yeah, there are a lot of details to the study. So we define a consumer as relevant based on a few, let's say there are broad rules you can apply. The biggest rule we apply is distance. So that's the rule that I talked about in the presentation of assuming, if generally if the demand is 3 kilometers away, it's DSO from the EHB, it's DSO relevant. Between 1 and 3 kilometers away, there's a question mark, and under 1 kilometer, we assume it's not DSO relevant. But on top of that comes a list of assumptions depending on the nature of the demand. So, for example, for households, we are we are certain that households are not going to be directly connected to the EHB or to the CAN nets. So to the extent that hydrogen is used to heat households, they will almost certainly be that demand will be DSO relevant, even if it is a house right next to the EHB. The same goes for small industry consumers. So you can imagine kind of bakeries or other kind of, let's say, Lackereien, like Paintwerkstätte, that have kind of high temperature processes or medium temperature processes that might require, or that will probably require hydrogen, but are not massive consumers such that they're not going to be attached to the EHB. So we also assume for kind of those small industrial consumers that all of their hydrogen demand is going to be DSO relevant. And then when you get to other like large industry, then you start really only working with the distances, because there you assume, okay, they could be TSO or DSO relevant. It really depends then on their distance. And when you get into transport, transport I might have to review on my own. It's been a long time since I've done the study, but I believe there we did some assumptions around
Yeah, we did.
whether the demand was,
And it was something like 30% of stations will use hydrogen, or 30% of vehicles, or, there were some assumptions. I think also, Anna, to
Yes, we
add that,
also said by truck for transport. You're
yes,
correct on that. So for
yeah,
transport, we did the distance, but then we also said at the furthest away, those are going to be supported by truck. So refueling stations will have kind of hydrogen trucks that go and service them. And I think we
yeah,
made some assumptions on, you have the normal distance that's too close to the EHB, but then also the furthest
yeah.
20% will be serviced by truck. And that's also explains why the transport DSO relevance a bit lower than the other sectors. So
I think we should add, Anna, to Mr. or Ms. Anonymous, that we assumed that everyone that could have hydrogen will have it. So that we didn't say 50% of people don't want it. I think to answer the question also, any emitter that cannot be electrified, cannot use electricity, we assumed will the hydrogen demand. So we assumed that everyone that could
for the
use it will use it.
Yeah, that's a good point. So that's on kind of the distances being DSO relevant. On the actual demand itself, so that comes back to the scenarios, and the scenarios we take from the
Yeah.
TYNDP That is a network development plan that estimates hydrogen, biomethane, electricity, all kind of fuel sources you can imagine demand for each of the European countries. It is developed by TSOs generally, who kind of input into their demand estimates. And so they would have already considered how much demand in a certain, and it's also sector level, how much demand would rather go to biomethane, for example, or to electrification processes. And they make a whole host of assumptions on the underlying technologies that determine that demand.
And we also, in areas with high biomethane potential in the scenarios, country by country, we reduced the demand for hydrogen. We added a factor, so we assumed that the biomethane would be the number one fuel. Thanks, Anna.
Okay. Thank you very much for this big answer.
Sorry, yeah.
No problem. I think it's great for everyone here to have the context and the background for all the valuables and variables
Variables,
in
And you know,
the
when you
study.
deal with scenarios, scenarios are just scenarios. They're not
Yeah.
reality, and they might never happen, but they're pretty realistic scenarios. Yeah.
Yeah. Okay, then let's come to the next question from Gunther Drischel. You should make this study also available for other stakeholders if you really want to succeed in Brussels. That's not a question, but more a commentary, but I think
I can
it's
comment on the
also.
comment. Gunter, you see the grid, our communications grid. We are connected. We have monthly meetings and MOUs with those 7 associations that are all based in Brussels and all have their own advocacy. So absolutely, everyone who should have heard this messaging has already heard it, and that's the whole point. Like we don't do research. Sorry, any results are absolutely made public, and that's why Ready for H2 only succeeds because it's part of the network. It brings all the key aim was to avoid gaps in knowledge and to myth bust. You know, you see one piece of information from an association, maybe another one from another. You know, we have all the same information and everyone agrees. So thank you, Gunther, but we're one step ahead of you.
Okay, thanks. Another anonymous question. I don't think if I understand it correctly, is it volume unit for H2 demand? Or I think,
Yeah.
is there a
Yes.
volume unit for H2 demand?
Yeah. So if you're looking at our absolute results and not the percentages, we're using terawatt hours per year. So that would have been, I think, in Germany, national 318 terawatt hours per year in 2050 on that graph. I tend to work better with the percentages. I think the messages are a bit stronger, they're a bit easier to read, and they're less scenario dependent. So I mean, you can kind of take whatever number you want, but if you assume sort of generally the same proportions within a sector are going to be kind of hydrogen relevant versus other fuels, then the percentages are a bit more, let's say, robust to other kind of estimates of national demand. So we do have both. It's terawatt hours per year, but I prefer the percentages.
The slides show the table with the numbers and the text as the percentage. And if you're a member of Ready for H2 or able to be a member through DEFA-GOVEI, you can get the exact results from the study and look at all the results.
Okay, thanks.
Yeah.
Then we've got, I think, our last question. So you got the chance to write 1 or 2 more questions. So we got 5 more minutes time. But for now, the last question is, why is Poland not involved yet in Ready for H2?
Poland is a member because gas DSOs and associations have limited budgets, and sometimes they have to choose. There are 8 initiatives. There are 8 associations in Brussels. You can be a member of GEOD, Eurogas, GD4S, Ready for H2. They have to make a choice. We promote hydrogen only. GD4S, for example, promotes biomethane number 1, hydrogen number 2. Poland is big on biomethane. So they decided, they were a member of Ready for H2, but then GD4S was started a few years ago and has become stronger. So they are a member of GD4S, for example. Same with Portugal and Italy. They were part of Ready for H2 at the beginning, but biomethane has become more important for them. So we can only do the research with our members. Actually, Poland says they might join us, and we're hoping they'll join us. Um, but that hasn't happened in the last few months. So we're membership driven. We would love to do our studies for the whole of Europe, but of course it costs money and it's a privilege for our members to get these results. That's the answer. Ukraine is a member, but you'll notice that they weren't part of the results because literally they're putting out fires and they don't have time to give us data and find data and review reports. So they are a non-active member, but we include them where we can.
Okay. Then I will look through our questions, but I think that's it for now. And
I think we just received 2 new ones.
two new ones.
You're looking at the chat.
Yeah. I'm just a little bit confused with our with our board. If you see them, Anna, just
Yeah, I
Yeah,
can
you
see
want me
you.
to read them?
yeah, just read them.
I think this one's for Barbara. What are the biggest obstacles for the H2 ramp up right now in your perspective?
Yeah, supply and
Hmm.
demand. We don't have contracts. There aren't any contracts for hydrogen, and we're not importing hydrogen into Europe or developing much of it. Um, there's loads of grand plans. What's really exciting is Cascade is leading, will operate an offshore pipeline. It's called Aqueductus. It goes from the west north coast of Germany and Holland out to the two new areas where they're going to a lot of wind power be built, an electrolyzer on a platform. Cascade have also started filling the first part of their large flow project. And the flow project is about 1,300 kilometers of pipelines from Germany right down to the south of Europe. But they don't have any off-takers. They're filling it up. It's like a pilot project. And the offshore pipeline bringing hydrogen in is expected to be operational in 2030. So I think the biggest challenges are there's no hydrogen being imported and no one sitting there going, we want hydrogen tomorrow. It's all still a few years ago. There's uncertainty, the pricing. There's a lot of, whenever you talk about hydrogen, someone always says, oh, it's super expensive. People do not look at the whole of the value chain. If you take renewables plus the intermittency, plus congestion in the grids, plus the need to triple the electricity grids in some places, you'd be quicker and cheaper using hydrogen. So people tend to look at the cost from the electrolyzer and say it's too expensive. So we need to change that mindset. And something I've learned from our members in the pilot projects is often customers just didn't know that hydrogen was an option. So they just don't choose it. And they go down the electrification route or some other route. So
Yeah.
those are the key challenges. No one answer.
Okay.
All solvable, but challenging.
Very good. Then we have one last question, sorry. What about households? In
Yeah.
Germany, hydrogen for
Yeah.
heating in households is seen very critically. How is this assessed in other countries?
Well, Anna, you may wish to mention the Eastern countries where the main
Yeah.
reason for hydrogen was buildings, housing.
Yeah, I can talk a bit about how the study deals with it and kind of insights that have come out from the conversations with Ready for H2 members. And then if Barbara has anything to add on more generally,
Yeah.
she might be better placed. So in the study, yeah, how like we definitely know households across various countries, so especially actually in Spain and France, and but also to a lesser degree, but also in Germany, that hydrogen for households in heating is just generally not seen as the most optimal, let's say, heating method for those for that sector. We dealt with that by saying, okay, I mean, the TYNDP does estimate hydrogen in the heating sector for Germany, so I think it's around 90 terawatt hours per year. It estimates higher values for other fuels. So we said they're probably going to, like, where will that occur? That will probably occur in regions where hydrogen already exists and is already necessary because of large industrial customers. And so when we did the regionalization, we first said, okay, where are the industrial customers that will consume hydrogen? And then said, and how many households are there? And we used, there's like some Copernicus land cover database that gives a really granular, I think it's like 100 meters or 1 kilometer on like where households are located. And so we used that in combination with the industrial demand, which we had at point coordinate level to say, okay, here's where those households will have it. Although we did find that in other, like I said, it kind of is very country specific. So in France and Spain, you see very high electrification and then also a bit of biomethane there for household and buildings. But for Slovakia and the Czech Republic, you see really high, proportionally really high hydrogen demand seen there for households and buildings. I think one of the stakeholders told us that 70% of their, I think it was financial, so like of their revenue was actually coming from gas being used within city gates for households and like, small kind of services buildings.
Yeah, I would add, if you look at the slides or the report when it comes out, you'll see that in 2050, Czech and Slovakia look very dark. That's mostly residential. So, yeah.
Okay. Thank you very much. Yeah, that brings us to the end of today's event. Once again, thank to you, Barbara and Anna, for the presentation and for answering all the questions. A big thank you also to all our participants for the lively discussion. The next Lunch and Learn on energy topics will take place at the end of August 2025. We will take a short summer break and we will keep you informed via our website as soon as the date is confirmed. Thank you for tuning in today, and thank you again, Barbara and Anna, for your fascinating presentation. See you next time in August. Goodbye.
Thank
Vielen
you.
Dank. Bis bald.